Okay, you guys, so right now we're going to work on 6.4, which is basically the easier version of graphing sine and cosine. And then in 6.6, we're going to do the harder version with phase shifts and everything like that. So this section probably won't be too bad. 6.6 is kind of like the catch-all section for all of them. 6.4 and 6.5, it kind of takes everything now and steps it up a little bit. So I just want to talk to you guys about the sine graph and the cosine graph. So these are periodic functions, functions that repeat their values in a regular pattern. They're oftentimes referred to in your book as sinusoidal. Sinusoidal just means that it's based on sine. So remember how we said that the cosine function is the same as the sine function, just shifted over a little bit. So that is why they're both considered sinusoidal. So what we're going to do is it's almost like you want to think about you're taking this unit circle, and it's almost like if you marked off all these locations, like right here, right here, right here, right here, so on and so on, and you like wrapped a string around it. That's kind of the idea behind what we're doing, and then we put it, on this graph over here. So what we're going to do is we're going to graph the basic sine function. So I want to graph y equals sine x. So what I'm going to do is I'm going to prepare like a little table of values. Okay. And then on this little table of values, I'm going to have sine of x, and I'm going to have x. Okay. So 1, 2, 3. And normally you do 5. They call it the 5 key x values. So you basically want to find the values that make the peaks and the valleys and the x-intercepts for the graph, or some version of the x-intercept. Sometimes you end up moving the x-axis in comparison to the sine or cosine graph or tangent. You shift it a little bit vertically or horizontally, and then it changes what your, in a way, like what your new x-axis is. So if we take x, we know that our x value here at this location right here, our x value is, I'm sorry, not our x value, our angle is pi halves. Well, I'm sorry, 0. So we're going to put a 0 in there. And then when we put a 0 in there, what's the sine of 0? Well, the sine of 0 is the y coordinate. So that's 0. Okay. Oh, that's why I was messing me up. I was looking at the cosine function, not the sine. So now when we take x is equal to, and in this case, x is the angle. Remember, it's inside the sine function. So when we say that the angle is worth pi halves, that's another good one. That means that x will be worth, or I'm sorry, y will be worth 1. Yeah, I got to switch it up. So remember, this is associated with y, right? So I think I was incorrectly saying the x value. But remember, the sine function, what it spits out, what the outcome is after you plug the angle in, that is what will become your sine function. So in this case, we look over here, and the sine, the y coordinate at pi halves is 1. We come over here, and the y coordinate there at pi is 0. The next one would be 3 pi halves is -1. And then the next one would be 2 pi, and that would be 0. So now what I'm going to do is I'm going to plot these points. So I have my angle x is worth 0, and then my y value, my outcome, remember it's y equals sine x, is worth 0. Then I'm going to go over pi halves, and then I'm going to go up 1. So I'm going to go over pi halves and up 1. I'm going to go over pi and up 0. I'm going to go over 3 pi halves and down -1. And then I'm going to go over 2 pi and up 0. So here's how you do it. You draw like these curves. And that is one period of sine x. Okay. So these locations are what we normally consider the 5 key x values. So we want those locations where it crosses the x-axis or the midline, and then where it creates a peak or a valley, okay, a maximum or a minimum, okay? In general, we talk about oftentimes using these 5 key x values. Okay, so no big deal. So now let's look at something in this form. A sine of, they'll refer to this as omega, so omega x. So basically what this means is that not everything is going to be nice and clean, just plain old sine x. We have to be able to adjust. So we're going to do y equals a sine omega of x. Now the thing is, when there's a value inside here with the x coordinate, or I'm sorry, with the x, you have to use that to adjust the period, okay? So the old period is in general 2 pi. For sine or cosine, your period starts off as 2 pi. And then you adjust it by doing 2 pi divided by omega, okay? So in this particular problem, we're going to do new period. So our period will be equal to 2 pi divided by, in this case, omega is 2. So we're going to divide by 2 and we get pi. So that means that you remember how before in this one, it was way over here at 2 pi, and that was 1 period. Now we're going to go over here just a plain old pi, and that will be 1 period. And then what I like to do normally here, I'll write it out for you guys. What I normally like to do when I'm doing these is I normally just like make a value here at the end, and then I just cut in half, cut in half, cut in half, and that way I get my 5 values, right? So I have a period of pi. So I know from here to here, there's no horizontal shift or anything, so I know it's going to end here. So what I'm going to do is I'm going to build my little table. Okay. And this is going to be my x, and this is going to be my negative sine of 2x. And then I'm just going to plug in my values. Oops. Okay. Yes, I don't like the way that looks. Let's go 1, 2, 3, 4. Okay. All right. So there's a couple ways you can do this. The main way that I like to go is, how do we know what values to pick? Well, what you should always do is take your period. So take the period and divide by 4. So this means that we would have pi over 4. Okay, that's how big each of the intervals are in between. So you see how here, from here to here was pi halves, from here to here was another pi halves, from here to here was another pi halves, and from here to here was another pi halves. So that interval, when it goes from, increasing to decreasing, or, so on and so on with, crossing the x-intercepts, any of those key values, they had a pi halves in between them. And that was because the period was 2 pi divided by 4, which is pi halves. That's why it happened. So if we come over here, I have a period of pi, and if I divide that by 4, I get pi fourths. So a good starting point will be 0 still, right? And then I'm going to add a pi fourths to it. Okay, and then I'm going to add another pi fourths, but that'll become pi halves. And then I'm going to add another pi fourths, but that will become 3 pi fourths. And then I'm going to add another pi fourths, and that will become pi. Okay, so that means my values are 0, pi over 4, pi over 2, 3 pi over 4. Okay, and then pi. So now what I'm going to do is I'm going to attempt to draw my graph. Now the only thing is it has a negative in front. So I got to be real careful with my values. So my value says when I plug 0 into this sine function right here, when I plug 0 into that, that's going to be the sine of 0, and the sine of 0 is 0, and then 0 times a negative 1 is still 0. But now when I plug a pi fourths into there, that becomes the sine of 2 pi fourths, which is the sine of pi halves. We come up here, sine of pi halves is 1, but then there's a negative in front, so this is going to become negative 1. Now when I put pi halves into here, right, when I put pi halves into here still, that actually becomes pi. So the sine of pi is 0. Okay, then I do 3 pi fourths. So let's see here, 3 pi fourths times 2 would be 3 pi halves. and 3 pi halves is back to -1, but there's already a negative in front, so this becomes +1. Now I plug pi in, that becomes 2 pi. Sine of 2 pi is 0, and the negative doesn't matter. So now I'm going to graph these values. Here's 1 or 0, 0. Here's pi fourths, -1. Here is 0 pi halves. Here is 3 pi fourths, 1. And then here is 0 and pi. So now I'm going to do this. Now notice it looks a lot like this graph up here, but it's like flipped. Well, that's because, just like with parabolas and all of that, you put a negative in front and it's going to do a reflection across the x-axis. So we did the same problem, but it just reflected it, and then we adjusted for the period. But it still looks like a sine graph. Sometimes, it speeds up or slows down in terms of how many loops you can have in between a certain value of your x coordinates, or not how many loops, but how many curves and everything. And it also depends on how many they want to see. Okay, so that's basically the beginning entry level sine functions. Now let's look at cosine. Okay, so let's find a cosine function. So let me kind of set it up the same. So now we have cosine of the form y equals a cosine, oops, I think I forgot to discuss something real quick. Let me fix this, omega x. So I forgot to discuss amplitude. Sorry about that, I got sidetracked. So amplitude, when we're talking about amplitude, amplitude is the absolute value of the number in front of the sine function. So whether it's -1 or +1 or 2 or -2, it doesn't really matter. That's how high the graph will go and how low the graph will go, the distance it will travel away from the midline, where a lot of times it's the x-axis, but sometimes you have to adjust the x-axis based on a vertical shift. So in general, we'll call it like the midline or the center line, okay, of the sine and cosine function. So amplitude is that distance that you travel, the highest and the lowest the graph will ever go. You could also think about it as, the highest value and the lowest value, and then cut them in half. That's the amplitude, right? If you add those and divide by 2, that would also be your amplitude. So now we're going to look at the cosine function. So let's graph this guy. So now the cosine function we know is 2 pi, so then this has to be pi. So this has to be pi halves, and this has to be 3 pi halves, right? And this has to be 1, and this has to be -1. So if we want to just graph y equals cosine of x, the base function, we know that the cosine of 0 is 1, right? And then, oops, let me do this. 0 is 1, there, 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 and there. So if I drew my table, and we had x, and then we had cosine of x, 1, 2, 3, 4, right? 5. So if we plug 0 in here, we get 1. If we plug pi halves in here, we get 0. If we plug pi in here, we get -1. If we plug 3 pi halves in here, we get 0. And if we plug in 2 pi in for x, or our angle, we would get 1, back 1 again. So all I did was I graphed this. And it's not like a V, it's kind of like this smooth curve, almost like a parabola. But now if we wanted to keep going, we would come and we would just keep going, and it would just keep doing this, right? It would just keep going down and just keep going up. And then if we went over here on this side, it would keep doing that. And it would end up looking just like the sine function, but just shifted over a little bit. So just keep in mind that the sine and cosine functions can kind of get confused because they look so close to the same. Let's try a little practice one. And again, I'm trying to use problems directly from your book because they use a different labeling than I do a lot of times. So I kind of want to use one similar to what you guys are used to. Okay, so let's see here. Yeah, I don't want to do that one. Let me find a better one. Let's do a cosine one. Yeah, let's do this one, I guess. Okay. So I'm going to tell you that I want you to graph using the 5 key x values, find the, and the amplitude. Okay, so this, again, this is the nicer section. It's going to get worse in 6.6. So let's say we have y equals 3 cosine of 4x. Okay, so I'm going to first build my little table, but in order to find my 5 key x values, right, I have to do this. I have to take the period. So the period equals 2 pi divided by omega. And in this case, omega is 4. So that means pi halves is my period. So that's actually pretty fast, right? That's, if you like zoomed out a little bit, this would look much faster, like it has a faster wavelength than the other sine functions and cosine functions. So what I'm going to do is I'm going to go right over here and I'm going to do pi half. Remember, that's how I started. And then I just cut in half. I cut each one in half. Because remember, if you want to know how much each one of those intervals is worth, you just take pi halves. Oops. And then you cut it into 4 pieces. So you could just do pi halves times, so 1 over 4. So that means we're actually dealing with pi over 8. So pi over 8 is kind of our starting point. I mean, I'm not a starting point, but the first number after 0. So we're going to make our little table. And we have our x, and then we have our 3 cosine 4x. Okay, so 1, 2, 3, 4, 5. Okay, so let's see what we got here. So we're going to take pi 8s, plug it in here. Now what happens when you take pi 8s and you add another pi 8? You get 2 pi 8s, but that's pi 4s. And then let's say you take another pi 8s. Well, that would be 2 pi 8 plus 1 pi 8. That's 3 pi 8s. And then if you take another pi 8, you get 4 pi 8s, but 4 pi 8s is actually pi over 2, which is what it should have been, right? Because it said we recycle ourselves. We start over after pi halves. So this whole thing is going to go again then. So what we need to do is we need to plug 0, pi 8s, pi 4s, 3 pi 8s, and pi halves into this function. Okay, so we have 3 cosine of 4x. So let's first find the cosine of 4x. So the cosine of 4 times 0 is 1, times 3 is 3. The cosine of 4 times pi 8s would be what? Pi halves. The cosine of pi halves is 0, times 3 is 0. The cosine of pi 4, so that'd be pi, that'd be -1, so that'd be -3. 3 pi 8s, that would be 3 pi over 2. So the cosine of 3 over pi over 2 is 0. And then the cosine of, that would be what? 4 over 2, so it'd be 2 pi. So it would be back to 1, times 3 is 3. So now I'm going to graph this. I'm going to graph my 5 values, my 5 locations, my 5 points. So let's go over 0, up 3. So let me label this. Hold on real quick. 1, 2, 3. -1, -2, -3. So 0, 3 is right here. Then this would be pi 8. This would be pi over 4. And this would be 3 pi over 8. So this work over here, you guys, this is like your scratch work. You need this. This is necessary to do these problems. Okay. So now let's go pi 8s, comma 0. So that would be right there. Don't mind this little green dot right there. I just don't want to risk erasing it. Well, maybe I can get it. Let's see. Nope. I knew it. Okay, so now we got to go pi force -3. And then 3 pi 8 is 0. And then pi halves is 3. And again, sometimes in your book, they're going to ask you to draw more than one period. That's okay. It's pretty straightforward once you kind of get the idea behind it. Okay. So, and it's like this smooth curve. It's not supposed to be like this sharp edge. I'm trying to make it this smooth curve at the bottom. Okay. And then this looks like, yeah. Okay. So that's our cosine function. And now if you look over here, it looks very similar to that cosine function. It's just, you know, the period changes the where it ends and everything like that. And we're going to do phase shifts that change even more of that, or horizontal shifts, whatever way you want to learn it. So that's basically how you do. And if, and I don't know how particular your homework's going to be, but if they want the 5 key points, so they may get fancy with it, well, then you just have to tell them that it's 0, 3, pi over 8, 0, pi over 4, -3, 3 pi over 8, 0, and pi over 2, 3. So these are the 5 key points right here. It's the same as the table that's above in green. It's just they might ask for the actual coordinates. And, you know, you can just go and label them. So this one right here is, you know, pi over 4, -3, right? And you could find all these points and label them if you wanted. All right. So let me see what else we got. And again, I'm trying to use something similar to your book. So I'm using some of the problems that you guys will have, because they use different letters than I do. I use a B and they use an omega. So I kind of want to keep things similar to what your book's using. Okay, so just so we're clear, in this problem, we found the period. I just want to be clear on all this. Let's try this. So we found the period, right? We found the interval size. So this is the interval size, right? So we found that. We found the 5 key points, but what we didn't find is amplitude. So we have amplitude is equal to the absolute value of A, and in this case, A is 3. So the amplitude was 3, okay? Now the thing is, think about it. How far is it from this value to the middle? And how far is it from the middle to this value? Well, it's 3 in either direction. So that's what it means to be the amplitude, okay? So that's not too big a deal. I just wanted to make sure I discussed it. I left that out a little bit. Okay, and they asked for the amplitude, the 5 key X values, and state the amplitude. So we found you can find quite a bit on these. It just depends on how far the problem wants you to go. Okay, so let's try another one. Let's try to graph using 5 key points and find the amplitude, or state the amplitude, I guess. So the problem they're going to give us is y equals, now this will take it back to sine for this one, 2 sine of negative pi over 2x, right? And then we're going to get our little graph set up. So hopefully you guys are getting the idea. Go ahead and pause the video and see if you guys can do all the setup like I'm going to do. Okay, so first thing you guys always have to do is find the period. So the period is equal to 2 pi, because it's a sine function, divided by, oops, I don't think there was a negative in here. Sorry about that. This is just a plain old positive pi over 2. And this is a negative. I messed that up. So it's 2 pi divided by pi over 2. Well, that would become 2 pi times 2 over pi, would it not? So then that becomes cancel, and that becomes 4. So our period is now 4. Now what we do is we want to cut that. So our interval size, we're going to take 4 and we're going to divide it 4 ways, and we get 1. So we now have 1 for our interval size as well. Okay, so that means right here, I'm going to put 4, then I'm going to cut it and cut it and cut it. That's a little too big. Okay, so then this is 1, 2, 3, 4. And I'll even put 0 right here. Okay, now if I wanted, I could do the same over here. Okay, now we need to know our amplitude. And that's the absolute value of -2, which is 2. So we got our amplitude. So we know we're going to go up 1, and here's 2, and we're going to go down 1 and down 2. Okay. So we have quite a bit of information, and now we're just going to build our little table. So x sine, oops, not sine x, sorry, it's much worse than that. -2 sine pi over 2x. And again, don't lose track. Why did I divide up here? Why did I divide the period by pi over 2? Because that's omega. Omega equals pi over 2, right? So that's why that guy goes right there. Okay, so whatever number is in front of x, that's what you divide your period by for sine and cosine. Okay, so now we want 1, 2, 3, 4, 5. Okay, so what we're going to do is we're going to pick our key x values, but this should be pretty good, right? 0, 1, 2, 3, 4. Okay, now when we plug 0 into this guy right here, that's going to be sine of 0, which is 0, times -2, which is 0. Now we plug 1 in there. That'll be the sine of pi halves, which is 1, times -2 is -2. Now we plug a 2 in there. That becomes a sine of pi, but the sine of pi is 0, times -2 is 0. Then we plug a 3. That's pi halves. So the sine of, the sine of 3 pi halves is -1 times -2 is back to +2. Now you plug your 4 in there. That'd be what, 2 pi? The sine of 2 pi is 0, and so we're back to there. So now we can graph. So we're going to go 0, 0. We're going to go over 1, down 2. We're going to go over 2, up 0. We're going to go over 3, up 2. And then we're going to go over 4, down 0, or up 0. Okay. And if we wanted, I kind of already know how the rest of this graph is going to look, right? So it's going to go up here at -1. It's going to go to 2. Then it's going to go here. Then it's going to go here. And it's going to go back to there. So I could graph very quickly 2 periods of this because I know now how this graph behaves because I've done so many of these in my lifetime. You guys will also do a lot of these. Okay, so we could build a different, where if they wanted to start at -4 and build it, we would do the same exact graph, but it would just be on the left side of 0 instead of the right. So we found everything we needed. We found our 5 key x values. And again, they might ask you to put it in point form. That's okay too. You guys got that. That's no big deal. And also notice it started off downward. It started off down here, but once again, that's because it was a reflection. It was because it was this -2. So hopefully you guys are getting the hang of it. Let's see here, how much more we got. I think there's one. Let's see how we could do this. Yeah, I think that might be okay for now. Let's go ahead and stop the video. I don't want to make it too long. I still got to do a couple more for 6.5 and 6.6. But yeah, you guys, this should get you started on using the 5 key x values. Where did I draw that one so far down? There we go. Using the 5 key x values to graph sine and cosine functions. And again, these are the nicest ones. It's going to get worse. This is as good as it gets for us. But it's important that you guys know how to identify omega and the amplitude, and then how do you decide your interval size? Will you divide by 4, whatever the period was? So these are all important things you need to know. But that's going to do it for this video. Thanks for watching.